Thank you very much. Of course, I won't present the whole material I've prepared because it comes from previous presentations and is part of the didactic materials for students. But the essential topic is that usually Galileo, we are used to think that Galileo was very, very cautious in dealing with hypotheses and with speculations about, for instance, the structure of matter and the composition and structure of a matter. And he was actually when the question was writing and exposing such hypotheses, but he was at the same time very interested in the topic because it was a strategic topic to explain and to give a full account of, for instance, the resistance of materials, the problem of the question of the floating bodies, and the study of heat and the attempt to measure the quantity of heat. And the problem of the structure of matter comes on the foreground in his reflection. And the source, one of the main sources of for him was certainly Sanctorius. And in my talk, Sanctorius would play a key role. We have a few sources from Galileo's writings in which he deals with the problem of, with a hypothesis of, with an atomic corpuscular hypothesis of the structure of matter. And first of all, his correspondence with Giovan Francesco Sagredo and the Saggiatore, which is the main place where he tries to outline a very open and sketchy theory of the structure of matter, and Benedetto Castelli, letter 1638, letter to Ferdinando Cesarini. We would can say that the challenge for Galileo since the Paduan years was to indirectly measure the action of fire corpuscule, fire particles on material bodies by measuring the effects or the effects induced by the presence, by the action of fire, without trying to measure or to quantify, to weight the amount directly, the amount of fire acquired or released by a body. And the thermoscope, the so-called thermoscope, was precisely designed probably in the around 1603, 1604 for this task. So to study, trying to quantify the amount of fire and the action and the heating action of fire through the effect of, we would say today, thermal dilatation. In the specific case of air, in the thermoscope, and we will see the later development. Okay. So this we'll skip this. Okay. 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 This is Viviani racconto storico. Sorry? And this is Castelli letter to Cesarini, reporting the instrument and describing the instrument. Okay. Okay. And probably when Castelli describes in his letter the apparatus, the thermoscope, he also has in mind his collaboration with Torricelli in the same years, because they collaborated with, on developing the original idea of the thermoscope. And we come to Santorius, which plays a key role in this story, because he's as a physician and committed with atomism, with corpuscularism, is the main source of Galileo's reflection in the Saggiatore on the relationship between heat, fire, light, and atomistic or atomic corpuscular structure of matter, because we know that also from the correspondence with Sagredo, that Galileo was interested in the Santorius publications, and especially on his commentaries on Galen and the commentaries on Avicenna, because they contain most of Santorius' theories. And we know that he is one of the pioneers of the quantitative methods in medicine. And I cannot, okay. The idea, and the Ars Medica too, the idea that the body is composed of corpuscular material particles that continuously exchanged with the environment, and that we can study the physiological processes like nutrition, digestion, growth, and even we can measure the things like fever and the pulse and heartbeat in order to study the body as a complex system made of corpuscles and particles. And the corporeal heat, bodily heat, is at the core of Santorius' investigations, because heat is identified as one of the main factors of life. And Santorius, in the same years, at the beginning of the 17th century in Padua, develops his own instrument. We would say a clinical thermoscope, or applies the thermoscope to study the bodily heat and trying to measure the temperature, bodily temperature. And he understands that the lower vessel has to be closed in order to isolate the thermoscope, which maybe is on his way to become a thermometer, because Sanctorius applies a graduated scale, in order to isolate the instrument from atmospheric pressure. Otherwise, the atmospheric pressure would influence the behavior of the instrument. And so Sanctorius is credited for this first fundamental modification of the thermoscope, in addition to the application of a graduated scale, probably more than one. There's not yet a defined standard for graduated scales, but his studies on the bodily temperature and on the pulse and the heartbeat are in the same period, belong to the same period when Galileo presumably conducted his own inquiries on heat, and we know that since the very beginning the influence between the two is mutual. So there's no question of priority. Sanctorius strongly influenced Galileo's agenda, let's say, and vice versa. And Sanctorius was on its own very interested in what Galileo was doing. And we know that Sagredo in Padua and in Venice was, so to speak, rivaling with Sanctorius in developing and in upgrading the instrument, as we know from his correspondence. And this is a recent volume on Sanctorius in 2022, a general overview on Sanctorius' work. And we know that Sanctorius, Galileo, and Paolo Sarpi belonged to the circle, the intellectual circle of Andrea Morosini. And it's highly probable that Paolo Sarpi, who met Giordano Bruno in Padua, was the informal vehicle of this model, this very peculiar model. We would say a mechanic, an atomistic corpuscular model, so a hybrid model, which is which comes from Bruno's Latin poems, and combines atomism and corpuscularism. And okay, just Sanctorius' mind. And this hybrid model assumes that material substances are composed by homogeneous particles, but they, on their own, in their turn, they are ultimately composed by atoms, indifferentiated atoms, very fundamental constituents of matter. And this is another important issue. These fundamental atoms coincide with ether and light. So matter, the ultimate resolution of matter, coincides with light. And this is something that Galileo directly reports in the Saggiatore. And in this view, heat is explicitly explained as agitation or motion induced by fire particles across the interstitial voids among material corpuscles, which are complex aggregates of these fundamental atoms. And on their turn, fire particles, which are the simplest particles, are composed by elementary atoms, so that fire has its fundamental resolution in light. And this is the way in which Galileo, especially in the Saggiatore, reinterprets the refrain motus est causa caloris precisely through this framework, and presenting this hypothesis as some thoughts of mine in a very cautious way. And the relationship between, we can trace linguistic items like transpiratio, transpiration in the Saggiatore, which directly link these passages to Sanctorius' works. And this is an explanation of how the model works. And the movement, the motion of the fire particles is the coessential with the phenomenon of heat. So not just the presence of fire particles, but their motion. Their motion becomes the fundamental explaining mechanism of heat generation and propagation. And I will skip this. Okay. And Galileo gives also a brief account of what light could be in this. Probably the light coincides with three atoms, three fundamental atoms, ultimate atoms, moving in space or expanding in space. And around 1623, Galileo still doubts if light propagates with an instantaneously, so with an infinite velocity, or with a finite velocity. We know that in the Discorsi, he describes an experiment to trying to measure the speed of light. And this is the quotation from the Saggiatore. Yes, yes. And the question of explaining heat and how to account for heat comes directly and enters the question of floating bodies through the question of how interstitial voids are involved in the different properties of matters and in the density of substances. And the case of water ice and the counterintuitive case of water ice is a key issue in this view. And along with other questions related with both with the problem of floating bodies and with the question of how to account for the phenomenon of ebullition and evaporation. And one final remark. Galileo in the Saggiatore and in the Discorsi is also interested in this issue of interstitial voids, because the problem is cohesion and resistance of material in the Discorsi, and one of the issue is to link the presence and the dimension of and the concentration of voids in matter and the resistance of the material. So the idea is that the smaller and the the smaller and compact these voids are, and the more resistant is the material. While materials with larger voids, even if less voids, are more fragile, like water ice.